In this lesson, we're going to be looking at scale factors and how it affects the areas of two-dimensional shapes. In the previous lesson, which was section 8.3 and 8.5, we looked at how scale factors affected scale diagrams and making things bigger or smaller via a scale factor. Now we're going to see how those scale factors affect area. If you're in my class and you have your study guide open, this is a do-it-yourself activity, so I will regularly, so you may want to pause the video and try it yourself, because you will learn more if you try some of the activity and discover some of the things yourself. Okay, so this activity is investigating how scale factors affect area, and the length of each square in this activity is 1 centimeter. So given each scale factor, draw the new rectangle and answer the following questions. So here's the original rectangle that we're going to focus on for this entire activity. So the dimensions of this original rectangle are 6 centimeters by 3 centimeters, and the area is 18 centimeters squared because it's 6 times 3. So what we're going to do is let's see what the effect of having a scale factor of 2 is on the area. So if I applied a scale factor of 2 on the original shape, 6 times 2 is 12 and 3 times 2 is 6, the dimensions of my new shape would be 12 centimeters by 6 centimeters, which would look like this. So there is a 12 centimeter by 6 centimeter rectangle. I've applied a scale factor of 2, and the area there is 72 centimeters squared. And the question that now is asked says, how many times greater is the new area compared to the original? Now, does a scale factor of 2 also mean that the area is twice as large? And we'll find out no, that's not the case, because the new area is 72 and the old area is 18. And that, if we divide them, so the new divided by the original, we'll actually find out that it's 4 times the area. For those of you who are visual learners and kind of wondering why having a scale factor of 2 actually makes it 4 times the area, you can see here that there's actually 4 6 by 3 rectangles that fit inside a 12 by 6 rectangle. So the area is 4 times larger. If you understand kind of what's happening, you may want to try this activity on your own and pause it if you're in my class. We're going to see the effect that a scale factor of 2.5 has on the area. So a scale factor of 2.5 would make the measurements 15 by 7.5. So if you're looking at the particular rectangle and what it would look like, here's 15 and here's 7.5. So your new rectangle, if you apply a scale factor of 2.5 to a rectangle that is 6 by 3, there's your new rectangle, and the area of that rectangle, 15 times 7.5, is 112.5 centimeters squared. Now the same question is being asked, how many times greater is this new area compared to the original? Well, the new area is 112.5 and the original was 18. So that would be, if you divide those, you can try it on your own, you get 6.25 times greater area. So how is the scale factor of 2.5 related to an area being 6.25 times greater? That's something we're going to begin to answer. Lastly, a scale factor of 3. I've already drawn the rectangle for you. It's 18 by 9. And the area of that new rectangle, 18 times 9, is 162 centimeters squared. And it is, so same question, how many times greater is that than the original? It's actually 9 times greater. For those of you who are visual learners, you may want to pay attention to this. You will see that actually 9 6 by 3 rectangles fit inside of an 18 by 9 rectangle. So that would be kind of the explanation visually. So far we've looked at scale factors being enlarging. Now the next part of the activity is what happens when we use a scale factor that's less than 1 or make the original smaller. A scale factor of 0.5 would make the original 6 by 3 rectangle into a 3 by 1.5 rectangle, and that area, 3 times 1.5, is 4.5 centimeters squared. So the question is, to get the area of the new rectangle, what would you multiply the area of the original rectangle by? So same type of question, except it's going to be a decimal number because it's getting a smaller area. So if we do 4.5 divided by 18, you are going to get 0.25. That's what you would multiply the area of the original by to get the area of the new, or you could always check that. What is 18 times 0.25? And you would get 4.5. Okay, so I'd multiply the area of the original by 0.25 to get the area of the new. Let's just do two more and we'll come to a conclusion. If I use a scale factor of 1/3 or 0.3 continued, we would get dimensions of 2 centimeters by 1 centimeter. So that would look like this. And the area would be 2 centimeters squared. So same question, what would you multiply to get the area of the new rectangle? What would you multiply the area of the original rectangle by? Or in other words, it would be 2 divided by 18, which is 0.1 continued. Okay, you could also check that. If I do 18 by 0.1 continued, do I get the area of 2? And I will. Okay, so 18 times 0.1 continued, and I will get 2. Okay, and last question, I've done most of the answer for you just to speed things up. A scale factor of 0.25 would make the dimensions 1.5 by 0.75, the area 1.125, and then you would multiply the original by 0.0625 to get the area of the new one. And you could check it. 18 times 0.0625 will give you this here, 1.125. Okay, so in conclusion, we'd like to come up with some sort of conclusion on this activity. And you may want to pause this after I explain it and try and figure it out yourself. It says, what is the relationship between the scale factor and what you multiply the area of the original rectangle by to get the area of the new rectangle? So in other words, what's the relationship between, this isn't in your study guide and you don't have to copy it down, what's the relationship between having a scale factor of 2 and the fact that you multiply the original area by 4 to get the new area? And that was the first part of the activity. What's the relationship between a scale factor of 2.5 and having to multiply the original area by 6.25 to get the new area? Or the relationship between a scale factor of 3 giving you having to multiply the original area by 9 to get the new area? So essentially, what's the relationship between all of those numbers? And if you want to pause it and look and see if you can find out what's the relationship between all of these numbers, you may want to do that. Okay, what I'm actually noticing here, and this is the conclusion that we're going to come to, is that all of these numbers in this column here, so what we multiply the original area by to come up with the new area, is always the scale factor squared. This is 2 squared. This is 2.5 squared. This is 3 squared. This is 0.5 squared. This is 1/3 squared. And this is 0.25 squared. Okay, so in conclusion, what's the relationship between the scale factor and what you multiply the area of the original rectangle by to get the area of the new rectangle? Here's the relationship. To get the area of the new rectangle, you do the original area times the scale factor squared to get the new area. That's the most important conclusion. Okay? And we'll apply that in the next couple of lessons.